So in the today's class, we are going to study about the applications of the diode. In that, the one of the application of the diode is rectifier circuit. Here, what are the rectifiers we are having in the sense? The one is we are having half wave rectifier. The second one is full wave rectifier. Rectifier. The third one is bridge rectifier. So now let us study each and everything, the principle, the construction and the working of the diode, as well as we are going to calculate some of the important parameters related to these rectifiers. Let us study about the first thing is half wave rectifier. Instead of before rectifier, first we need to know what is rectifier. What is rectifier? So it is nothing but, so it converts AC to pulsating DC. Or I can say simple. So it's a converter or it's converting. It is a converter or I will say it's converting. It is converting so it's converting from AC signal to DC signal. That only we can say rectifier. A rectifier is an electrical device that converts an alternating current AC into direct current DC by using one or more PN junction diode. Now what we will do, let us study about the first diode, that is nothing but a half wave rectifier. Or before studying half wave rectifier, let me show how the complete the structure of internet will be there. So let me show that. So this is nothing but a rectifier alternating current to DC current. And the alternating signal is AC signal. The output is a DC signal. So it contains three different types of rectifier circuit is there: half wave rectifier, full wave rectifier, and bridge rectifier. So now which I'm going to show, it's a complete a circuit of design of power supply actually. So this is nothing but it's a power supply. It's a power supply. Complete the full power supply. So it's with the transformer, rectifier, filter, and regulator. Normally, what will happen? The input will be your AC signal, which is 120. This is US actually. But in India, actually, what is that? You will have in India that is 220 volt, 50 hertz actually in India. In US and all, actually, they will use 120 volt to 60 hertz input signal AC. Actually, in India or in some other Asian countries, also we will use this only 220 volt to 50 hertz. So this will be your input signal which you are receiving in your home. Like there is a plug. You see this? There is a 2-pin plug is there. So now you consider what is this. This is a simple example. If you want to say, this is nothing but a one simple charger. You assume us like this only, your mobile charger. Okay. So now what you are doing, first thing is, as we are getting 220 volt, you are getting, but this 220 you won't get directly. What you will do, from the power station, the electronic, you might have seen EB office, right? So there actually we'll have that, and the roads and all you are seeing, so many transformers will be there. So actually there you'll have 440 volt. So in the transformer actually, so in the roads you will see the transformer. What the transformer will do, that will step down your voltage. That is nothing but from 440 volt to 220 volt, it will step down. Then that will give it to your home purpose. This is for commercial purpose. The 220 volt normally we use it for commercial purpose. So not to see domestic purpose, sorry, it's a domestic purpose. The 440 volt we'll use for commercial purpose. And now that will be given to the transformer. Here we are having a two different types of transformer. The one is nothing but step up transformer. The second one is nothing but step down transformer. So here we'll use which transformer in the sense? We'll use the step down transformer. What the step down transformer will do? Here we are having 220 volt is the input. When I give 220 is the input voltage, the transformer will be like this. Like I don't know whether you see, we'll have so many coils, like rotation of coils will be there. Then here we will give the input, here will be the output. So here I will give 220 volt is input. Here it will give you 12 volt actually. So that is, I can say here how much it will give. It will give 12 volt. Example I'm saying. Okay. So it will give the 12 volt in the sense, even here we are having AC. Then after the transformer, also I will get AC only. See this, the transformer output voltage is this. So simple, I can say this is 12 volt actually. After that, what you're doing, you need to rectify that. So that is why we are using rectifier here. Which rectifier are you using in the sense? This simple, I can say we are using them. Full wave rectifier only we are using here, because the after rectifier we cannot use. So the full wave rectifier, there is output waveform. So later I will show how it will be worked. So in the full wave rectifier, what will happen, instead of getting the complete cycle, just we got only half cycle. You see this. After that, what you will do, they'll go for the filter. That is filter in the sense. So you will have the rectifier with the capacitors they'll use in the output, because that is the capacitor only will perform the filtering operation actually. What will happen? You see this, the same waveform only here. See, like this, then we'll get like this, then we'll get. This is what we got here actually. Filtered outputs only we get. But still what I need to remove the ripples. See, these are the called as ripples. This only ripple or harmonic we can say. So this will be your VDC, but not a complete VDC actually. After filter, what will happen? The rectifier, what the rectifier will do? Rectifier, it will convert AC to DC actually. So that is what, see, after AF and see, this is the DC we got. So now VDC will get. We got the VDC here, but still I want the complete DC is that you got straight line we have to get. What you need? I need to remove this some ripples and all, or the harmonics or the distortions we need to remove. How it can be removed? At the same time, we need to get the constant output voltage you have to get. So what will happen? Once you get the filter voltage, that will be given to the Zener regulator or any regulator. It's called as voltage regulator, we can say. What this voltage regulator will do here, until here, you will get a 12 volt actually. So from this 12 volt, it can be 12 volt or it can be 15 volt or it can be 18 volt. It is depends upon your transformer actually, but the output is should be fixed. So that is what the regulator will do. What how much I want in the example I will say. So I may need a 5 volt as output. So what this regulator will do? The input is 12 volt, the output is 5 volt. So I will get the 5 volt, the regulated voltage. So that only will connected to the load. That is nothing but your application, or I can say this is nothing but your mobile. This is your mobile. Load is a mobile actually. So now that is the way the power supply is created. Now what we will do? Now we are going to study which part here. We are not going to study about the transformer part. We are going to study the rectifier part. We'll study. Then we'll study filter part. Then we'll study regulator part. One by one we'll study. So these three things we are going to study in this one by one actually. So that is what the rectifier only. Here we had three different types. So that is why. So let us start with the one by one. So the first thing is we are going to study, that is nothing thing but of wave rectifier. Okay, of wave rectifier. Okay. So first, so the half wave rectifier, what will do? Let us draw the diagram of a rectifier. How it will be there? See, this will be your half wave rectifier circuit. So now you can see in this half wave rectifier, your input is this. This will be your input plus and minus the input, right? So now this will be your this portion. This portion only is nothing but a transformer. As I said there, actually, right? This is the input voltage. This is the input voltage. That is the input voltage. How much? How much voltage? Input voltage. It is 220 volt, 50 hertz frequency. Very, very important here. The frequency, 50 hertz frequency. So this will be a transformer. Which transformer in the sense? It's a center tape transformer, because you see the center tape, we are having line. So this only indicates the transformer. This one we can call as transformer. Which transformer is? This only is nothing but a step down transformer. Here input is 220 volt, output we are going to get, like, see example, what is the output I'll get in the sense in this place? Vm sin omega t. That is output. The Vm is nothing but your magnitude voltage. That is what is that? So simple example I will say, 220 volt means the output of the transformer may produce 12 volt. Example I'm saying, I'm not saying exactly how much it will produce. It is depends upon how you are going to design the transformer. That how we will design the system, that is based on the number of turns of the coil, because the copper coil, with the copper coil they will turn actually. Now the Vm sin omega t, because the input is a signal, the sinusoidal signal. So sin omega t, where the omega is nothing but 2 pi f actually. So the f is nothing but the frequency which are using 50 hertz. That is why here we'll get Vm sin omega t. The input is nothing but same. Like this is nothing but now the proper input I can say. Right? Vm only. Vm sin omega t is nothing but your input. Now you can see here we connected here one diode, that is only one single diode connected. Along with the diode, we connected one resistance. That resistance is nothing but a load resistance RL. The output will be taken across from the resistor RL. Now let us see the operation, how we'll get. So before that, let me show what is the prediction of the output will get actually. The prediction of the output will be like this. See, this is what we'll get actually. The input is like this. So always again, I'm repeating, this is not 120. This is, you will consider as 220 volt, 60 hertz. Okay, sorry, 50 hertz. Rectifier, the output will be this one. So see, the input having full cycle. So I need to put the okay, this is zero margin. Okay, graph. So now it will give you only the off cycle. See, the positive off cycle only I'm getting output, the negative off cycle I'm not getting. But how we are going to get this? So let us see that. First, see, this is case one. You say like this only. Okay, I will put as case one. Case one, during positive off cycle input. Case one. Okay, just I'm putting an example as like this, during positive off cycle. Not what happened here. You see in this circuit. So now the input is like this. Okay, this is the input actually. So during the positive cycle means your VM. That is, the input is VM actually, or I can say Vin, anything you can say, right? So the VM is greater than VD, means that value the across the diode here, because this is plus, this is minus, this is VD. When this diode will be turned on, when the input voltage is greater than the VD, then only this will be work. Means the P is connected to positive, the negative is connected to negative. Then this will be the forward bias. So I can say the diode will be in forward bias. See, during positive off cycle, okay, during positive off cycle, the diode is forward biased. So diode is forward biased, then what will happen? Whatever the input, the voltage we're having, same thing I'll get the output. Correct? The amount of current. See, same thing I'm getting here across your load here. So that is nothing but, so like the current will flow over in this place. So diode is forward bias. I hope you might have understood now. So case number one, during the positive cycle. So during positive off cycle of the input, the diode will be conducted, in the sense the diode will be in the forward bias condition. Then the output will get us the one off cycle I will get. After that, what happened? The input goes your, that is nothing but what? V in, right? That is input. Input will go less than your VD actually. Means this is what? Negative off cycle. That is nothing but during negative off cycle. That is the meaning of that, right? That is during negative off cycle. During negative off cycle, that is only I can call as case 2 will call. So during negative off cycle. So now what will happen during negative off cycle? So during negative off cycle, what happen? The voltage, this voltage will be less than the VD. That is nothing but the diode voltage. The diode will be in the reverse bias condition. Because of the negative voltage you are applying, the input voltage is negative voltage, means it goes like less than that, it will be the reverse bias. When it is the reverse bias, so what will happen, the diode will be, it won't doesn't conduct, means the switch will be open, so there will not be any amount of current, so diode will be in off condition. If the diode is in off condition, what will be the current? So I can say here it will be 0, so I'll get 0. So the diagram will be like this, will get. I hope you might have understood now. See, this will be your negative. So during negative in the sense, what I'll get? So we'll get the output as 0. Because of what? The current will be is equal to 0. The reason is the reason will be the your input voltage is less than VD. Just during the negative off cycle. So like this, what will happen? Continuously the input I will get the waveform as like this. Finally, together I need to draw the diagram. See, I hope you might have understood now. See here, yes. So this will be your input. This is your input. So this will be your output. So now you can see here, this is the input waveform, right? So I will get the output. See that first half cycle. So for the negative cycle, what happened? For the negative cycle, so the D2 doesn't conduct, right? If doesn't conduct in the sense, what will happen? So this will be 0. See, that is what this. Next, again for the positive half cycle, what happened? This will conduct. See, for every positive half cycle, so diode will conduct. Only in the positive half cycle will conduct. So I can say here, we are putting as like a 0 pi, that is 2 pi. That is the for complete the one cycle is we are going to take is nothing but 0 to 2 pi. One cycle, full cycle you are going to take 10. So that is the interval actually. So this will be your frequency omega t. This is omega t. Now the peak, what you are getting the voltage, that is nothing but average voltage they will call normally. This is the average voltage, how much. Now your Vin is nothing but this. Now what about the current? Same, this is in terms of voltage. What about the current actually? The amount of current will also, the diagram will be like this. See, I can write as in this way. Even you can write like this, or you can write as like this also. How you can write in the sense, input, the current also. I can write as Im sine omega t. Even I can write in terms of current or in terms of voltage also. Here I written as V0. So this will be your, I can say, the peak is nothing but your Vm. This is nothing but a Vm actually. So same the way, even I can do for current also. Here, see, right? This is what I'll get. So this and all will be your this is 0 actually, right? This is 0 actually. So about current, this is example I'm saying. Here we took V in, right? Same if I say in current in the sense, this will be your Im. So you can take the derivations or the expression in terms of voltage or in terms of current. Keep it in your mind that. So this will be in terms of voltage. This is in terms of current. 0 to, this is pi, this is 2 pi, this is 3 pi, like this. So this will be your omega t only. Now what you need to do, we have to find out some of the terms which is depend on in the rectifiers. What are the terms? We have to find out. First, before that, in this circuit consists of the series connection diode D and the resistor R. So we assumed as the sinusoidal waveform. The input voltage Vi in our Vn will tell us Vm sin omega t. So same the way, now what we will do, let us go for some of the, I will show one waveform. So it will be very easy for you, or it will give you more interactive. See, input voltage, complete cycle, 0 to 2 pi. This is output current, this is output voltage. You see here, the complete, this will be your Im, the peak. This portion is nothing but your IDC. Same the way, this portion, the high peak is nothing but Vm. This will be your VDC because this is the DC, the clipping voltage. So now what we are going to do, we are going to calculate the factors are like, what are the things we are going to calculate in the sense? Let me tell some of the factors. That is nothing but we are going to calculate the peak current, that is Im. Peak current, average current. Im is nothing but peak current. Im is peak current. Then IDC is nothing but average DC current. Average DC current, or sometimes they may call I average, because sometimes book you can see like this derivations also. Then next what we are going to calculate RMS current. Next thing is we are going to calculate RMS, that is IRMS. They are going to calculate the term. The next term what we are going, that is IRMS in the sense RMS current. We can say as RMS current, that is I. This is what? Root means square current. Even this term also we need to calculate. The next term is we are going to calculate the VDC. Same, IDC means VDC also same. Then we are going to calculate the V0. The V0 is nothing but a output voltage. Then we are going to calculate the PDC. That is nothing but it is a DC output power, I can say. It is a DC output power. This also we are going to calculate. Whatever we are going to calculate here, it's applicable for everywhere. Next what we are going to calculate, that is rectifier efficiency. That is eta. That is nothing but it's a rectifier efficiency. Rectifier efficiency. This is called as efficiency. Next, we are going to calculate one of the important factor is nothing but gamma. That is called as ripple factor. Very, very important. So these all are the terms we are going to calculate for every rectifiers. If you do for half a rectifier, the similar procedure only to perform even for full wave rectifier also. Now let us start with the one by one. So what we will do, the first thing is let us calculate the average DC current. So before that, what we'll do, let us put the equation like this I. Okay, let me write the input I is equal to Im sin omega t. See here, this is nothing but out. Okay, in the output. So now what I will do like this. Now you can see in the output Im sin omega t, the output. This one, to which interval I'll get? Your interval, the input is from 0 to 2 pi actually, input, because you need to consider the half cycle, the first half cycle as well as the negative half cycle you have to consider. The first half cycle actually you'll see. So total interval is 0 to 2 pi actually, the input is right. What will be the output actually? The output is Im sin omega t I will get from interval of what? 0 less than that is omega t, right? Less than pi. Up to 0 to pi only I will get this. What about this? I will get as that is pi less than or equal to omega t less than or equal to 2 pi. I'll get the value as 0 will get. I hope you might have got it. So now what about the peak current, that is IM? So as per the Ohm's law, we know that IM is equal to Vm by pi. This we know very well. Vm by, not Vm by pi, it is Vm by, sorry, as per Ohm's law, Vm by R, that is L, because here load resistance. So Im is equal to Vm by RL. So this is nothing but your the peak current. This will be your peak current. Peak current. So you may think, so you have to calculate the Vm. So how will calculate Vm? So it's very simple. You can calculate Vm in simplest way. How will get the output? So now what you will do? Let us calculate the average or DC current, that is IDC. IDC or DC current or average current will be defined as, it is defined as 1 by pi, the interval of 0 to 2 pi, complete interval is 0 to 2 pi, right? 0 to 2 pi Im into, not Im, sorry, I into d omega t. I into d omega t. So what is I actually? We know that, see, 1 by pi from the previous year, you can say from 0 to pi, where I is nothing but Im sine omega t into d omega t, plus then again the second interval is nothing but what? Pi to 2 pi. Pi to 2 pi, what is the value of pi? It's nothing but 0. So 0 into d omega t. Once the meeting gets